mathematically speaking, from a distribution, this is what I need to find. Okay, this is actually what I need to find. Of course, you know how to get this, and you know what is this? This is just after the cube of the standard deviation. Does that mean saying the cube? You already know this. The sigma square is this, right? The sigma square is this guy, right? You know how to derive that. Okay, then the sigma is actually going to be square root of that, right? It's going to be square root of that, right? Okay, sorry. It's going to be square root of that. So the moment you get this sigma, you're going to raise it to power 3 here in the denominator. And from here, oh my God, the numerator here is the third moment about the mean that I've discussed today. The third moment about the mean. Okay, now that is for the skewness. This is for the skewness. Okay, that is for the skewness. The next one is actually when I record a 4. Okay, then I want to do this guy. What is the essence of doing this? Raise it to power 4. Okay, this is the fourth, we call this fourth standardized movement. The first standardized movement will enable us to get kurtosis. Okay, now what is the essence of kurtosis? Kurtosis measure, tail heaviness. Okay, so it measures tail heaviness and peak sharpness. Okay, let me tell you this. Some of you, I'm actually going to talk about this application of kurtosis in finance. Okay, do you know that high kurtosis? Okay, what is going to be the threshold? I think I need to first give you the threshold to be able to know. When you compute this guy and skewness equal to 0, then it means the data set is normally distributed. When skewness equal to 0. Okay, but when the skewness is greater than 0, that's a positive skewness. When skewness is less than 0, that's a negative skewness. Now, what is the threshold for kurtosis? Okay, I'm actually the threshold. The kurtosis of a normal distribution is 3. That is the standard. The kurtosis of a normal distribution is 3. When you get a kurtosis 3, okay, from a data set, that data set is telling you, oh, I'm normally distributed. Which we call mesokurtic. Okay, when the kurtosis is greater than 3, okay, that's always happen in finance. We call that leptokurtic. When the kurtosis is greater than 3, you are more or less high. Leptokurtic actually means higher risk, which means there's a greater chance of occurrence of extreme events. That's what it means. Greater chance of the occurrence of extreme event. Okay, situation where the kurtosis is greater than 3. Okay, I think I'm quickly going to write that so that you actually going to see the essence. Okay, like I said, we have mesokurtic, we have leptokurtic. Okay, and we have platykurtic or kurtic. Okay. Okay, so here, that is when it is 3. This is when it is greater than 3. This is when it is less than 3. Okay, mesokurtic indicates that the data set is normally distributed. Okay, and this is what we normally experience in finance. Okay, that indicates an higher risk. Okay, and also in quality control. In quality control, okay, high kurtosis in quality control actually will enable us, let me just say generally, kurtosis will enable us to understand and detect a deviation from a process quality, which means high kurtosis signal that there have been increase in the numbers of defective items. That is sending a red flag. So the moment you compute, you have a high cortices, which I call leptocortic, where it is greater than 3. Okay, that indicates in a manufacturing, it actually indicates, there have been increase in the number of defective. You don't want that. We need something in a stochastic world that will ring a bell when things are going wrong. And that is the reason mathematics is going to do a whole lot of job. Maybe at times we don't pay attention. Okay, they are real. We don't pay attention. They are definitely real. Okay, I think I've walked you through all of that, reason why we got that. That's a measure of skewness, like I said, and the one for cortices. So, like I said, we're not gonna go beyond faults. You remember the other time when I was talking about raw movement, I actually show you the first, the second, the third, and the fourth. When we're talking about central movement, I also talk about the first, second, third, and fourth. When we're talking about standardized movement, I also talk about first, second, third, and fourth. We're not going to go beyond that. Okay, now I'm going to use the rest of my time for movement generating function. Okay, like I said, our application is actually going to be on Friday. Okay, now I want to go into, now we have another alternative to all this. The method we've been using all this while, focus on movement, right? We now want to have a different method that we call the method of movement generating function.